Good morning friends. Today I am going to explain the one of the important topic in thermodynamics, that is work done in isothermal process. Before going to calculate the work done in isothermal process, first of all we should know what is isothermal process. Isothermal process means in which when a thermodynamical system undergoes a change in such a way that the temperature remains constant, then the change is known as the isothermal process. So first of all, what is thermodynamical system? Thermodynamical system is a system which consists of temperature, pressure, volume and entropy. So whenever such type of a thermodynamical system undergoes in such a manner where the temperature is remains constant, so that time that particular process or that time whatever be the changes are occurring, that is known as the isothermal process. So for that purpose, first of all we have to take a let 1 gram mole of an ideal gas. Ideal gas means which obeys the gas law, that is Charles law or Boyle's law. So that is known as the ideal gas. So let us consider or let take 1 gram mole of an ideal gas which expands isothermally as shown in a figure. So initially let us consider the initial state of the gas where the here in this total process we are considering temperature is remains constant. So when temperature remains constant, the initial state is represented by A. So this particular diagram is known as the indicator diagram. So in this indicator diagram, initial state of the gas is represented by A, where the initial pressure is Pi and the initial volume is Vi. So when it expands isothermally, so it reaches a point B. So where the final pressure is Pf and final volume is Vf. Okay. So now we have to calculate the work done from A to B. So to calculate the work done, whole work done, so in physics first of all we have to consider a small work done or small volume. So for that purpose we have to take a small C to D. The temperature is remains constant, and at the same time here we have to consider when the gas expand from C to D, the pressure and temperature both are remains constant, and for this small element dV, what will be the work done we have to calculate first. So after that we have to integrate the whole one, then we will get the A to B, what will be the work done. So for that purpose, first of all we have to write some points, that is let Pi and Vi be the initial pressure and initial volume respectively at initial state A, and Pf Vf be the pressure and volume respectively at final state B. Next, during isothermal expansion, both pressure and volumes are changes. We know this one. Temperature remains constant. Pressure and volumes are changes. Now, let us consider P and V be the pressure and volume at any intermediate state. So, at any intermediate state, C to D, the P and pressure and volume will be just P and V at intermediate state C. Here, we assume that pressure remains constant for a small increase in volume dV. So at this position from C to D, we have to consider the pressure is also remains constant. That is for increase in small volume dV. Then the work done by the gas. So then the work done by the gas during this small expansion is can be written as, so work is what? Force into displacement. In terms of gases, force is what? Pressure, and displacement of the particles is we can take in terms of volume element dV. So here the small work done can be given as P dot dV. Okay, and the net work done by the gas when it expands from volume Vi to the volume Vf is can be given as, just now I told you. So whenever you are calculating the whole work done, we have to integrate. So total work done is equal to integration initial volume to the final value P dot dV. Okay, we know that PV is equal to nRT. So this is the ideal gas equation. We have taken 1 gram mole of an ideal gas. So PV is equal to nRT for n is equal to 1, and for the isothermal process, for isothermal process, we can write PV is equal to RT, or we can write, so we need the value for the P, so that's why PV is equal to RT by PV is equal by RT by V. So in place P we can substitute the value of RT by V. So therefore W is equal to VI to VF, and PV is equal to, P value is RT by V dot dV. Okay. Now we can write this one here. W is equal to the your VI to VF RT into 1 by V into dV. Okay. Now we have to integrate to this equation. When you integrate to this equation, we can write W is equal to RT. So we know that integration of 1 by V into dV can be written as, take out the RT VI for 1 by V into dV. So integration VI to VF can be written as 2.303 log 10. So RT log, first we can log E VF by VI. So what is the value of log E? That is 2.303 log 10. So we can write 2.303 RT log 10, and this is VF by VI. So if initial and final volume be V1 and V2, if we take this one respectively, and P1 and P2 be the initial and final pressure, then the work done can be given as, that is W is equal to 2.303 RT log of 10. So just we are replacing VF and VI as V2 by V1. So this is known as the work done in isothermal process. Thank you. For more videos, subscribe my channel Physics.